All right, so we are going to do physics, AP Physics, page 44, numbers 33, 35, 37, 39, and 41. These will be mostly objects falling, going up in the air and falling, which means we are in the vertical direction. Before we even begin these questions, I do want to mention you should always try these problems yourself first. As far as you can, read the problem, set it up as much as possible, go as far as you can first before watching this video for each problem. When you're taking a test, you're not going to have me here doing it for you. So you might understand it pretty well as I'm going through it and feel pretty comfortable with it. But what happens when you see a problem and you don't know how to start it? So I do want you to try it on your own first and then watch the video. It'll help much more for preparing you for the test, okay? All right, so first let's write down the equations we have, the three equations again, but this time let's write them in the vertical direction instead of the horizontal direction. So we have Vy, meaning vertical, meaning this way would be right, positive y, negative y. We could flip-flop those, and I'll explain later. This way being positive x, negative x, okay? So Vy is equal to Vy0 plus Ayt. Now again, t just means time, right? So that's the same vertical or horizontal, but notice all the others have a y instead of x. That just means we're talking about velocity in the y direction, up or down. We're talking about the initial velocity in the y direction, up or down, and then the acceleration in the y direction. Okay, so we have y is equal to y naught or y0 plus Vy0t plus 1/2 Ayt squared. We have Vy squared is equal to Vy0 squared plus 2Ay times y minus y naught. So now it really just means all the same stuff that we were doing before, except now we're talking about only in the vertical direction instead of the horizontal direction. Okay, and eventually we'll have to do both, so we'll get there eventually as well. So first problem here, number 33. Okay, so the car rolls gently, V0 equals 0, off a vertical cliff. How long does it take to reach 90 kilometers per hour? So we have a cliff. The car is going to gently roll off the cliff until it's falling downwards. This is going to be our initial y0, we'll call 0 meters. Now I'm going to do problems in different ways. We can say downwards is positive or up is positive. For right now, we'll just call up positive. Okay, so I do want to label that. Up is positive y, to the right is positive x. We should almost always label that, by the way. Now its initial speed, Vy0 is equal to 0 meters per second. Same as gently rolling off the cliff and going to fall down. And it's wondering how long, meaning time, does it take to reach 90 kilometers per hour. So y0 is 0 meters, Vy0 is equal to 0 meters per second. What else do we know? We're looking for time. We have one more thing. Now, if you're reading the book, hopefully you know exactly what AY here is. If something is falling, it always falls at the same rate. I'll probably show some videos and explain this a little bit more in the future. But everything on Earth or near the Earth's surface falls with the same acceleration. And we'll talk why that is later when we get into forces and stuff. But for us, we are going to use little g is the acceleration due to gravity. It is on your equation sheet, and it's 9.8 meters per second squared. So if something is falling, it's always accelerating, or if it's flying up in the air, it's always accelerating with 9.8 meters per second squared. Now, this is, in our case, because it's downwards, we called up positive. That means this is negative 9.8 meters per second squared because it is going downwards. Okay, it's in the downward direction. All right, and that's it. So let's figure out which equation we're going to use here. It looks like the easiest one, well, the only one we can use because we don't have y at all, is the first equation there. So we have Vy is equal to oops, I forgot one thing. We do have the initial, the final Vy is going to be equal to 90 kilometers per hour, which I'm going to change to, in 1 kilometer, there's 1,000 meters, and in 1 hour, there are 3,600 seconds. So that would be, let me grab the calculator. Okay, now we'll go back. All right. So we have this equation. We are looking for t, so we're going to have to rearrange this equation to find t. So first, we've been doing this a lot, right? Subtract Vy0 from both sides, that those reduce out. Then we have Vy minus Vy0 is equal to Ayt. All right, and then we're going to divide both sides by Ay. So that reduces out, and we're left with, I'm going to flip-flop them again. Vy minus Vy0 is equal, divided by Ay is equal to t. All right, now we're just going to plug in the numbers that we have. So Vy is 25 meters per second. In this case, it's actually negative also. So we want negative 25 because it is going to be moving downwards, right, at 25 meters per second, which in this case is negative. So Vy is negative 25 meters per second minus 0 meters per second divided by negative 9.8 meters per second squared. And that's going to equal 2.55 seconds. So it's going to be falling for 2.55 seconds before it reaches 90 kilometers per hour or 25 meters per second. Now notice, if I had made a mistake there and put Vy as positive, then I would get a negative number. And again, you can't go backwards in time, so you can't get a negative time, which means you probably messed up a negative somewhere. Just for clarity's sake, I could have called downwards positive, and everything would have been positive then, but I would still get the same answer. So the positive and negatives really determine their directions. It's important that we stay consistent the whole time, so that way our positive and negatives line up correctly. All right, so I'm going to go to a new page here. So on to 35. Calculate A, how long it took King Kong to fall straight down from the top of the Empire State Building, 380 meters high, and his velocity just before landing. We're not given very much information here. We're only given the height of the building. So we have the Empire State Building, King Kong, who I'm just going to draw as a little person, is going to fall down, right? And we're looking for how long it took and what's his final velocity. So it's kind of amazing. We're not given a whole much information here. We're just given the height of the building is 380 meters. So this time, let's call downwards positive y, just to mix things up here and to show you that it doesn't matter. And to the right is positive x here. Okay, so if we call this y0 up here, and this would be y final. So I'm going to call y0 0 meters. That would make y final 380 meters. Now, it would be negative 380 if I flip-flop my numbers, or flip-flop my positive and negative. But here I'm going to call downwards positive, so it's going to be a positive 380. So let's list out our variables. Y0, 0, y is equal to 380 meters. Important thing here that we need to know, ay is going to be g, which is going to be, in this case, positive 9.8 meters per second squared. It's positive because we called downwards positive, and it is accelerating downwards, which is positive 9.8 meters per second squared. we are looking for A, we're looking for the time, and then for B, we're looking for Vy. We can assume, because he's falling, he's not going to like throw himself downwards, he's falling downwards. His initial y velocity, we're going to assume, is 0 meters per second. All right, do we have enough information to solve this problem? Well, if you look at the first equation, we don't, right? We don't know Vy, we don't know t, so we can't use the first equation. If we look at the second equation, we could solve for t because we know all the other ones. But you know what's going to be super annoying is having to do the quadratic formula, except we wouldn't because Vy is 0. But either way, usually when I look at that, I'm like, oh, I don't want to do the quadratic formula, so I skip it. So I look at the third equation there, and that's the one we're going to use. So we have Vy squared is equal to Vy0 squared plus 2ay times y minus y0. And we are looking for, well, let's just do, so if you wanted to do a first, you could by doing the second equation. You won't actually need the quadratic formula because Vy0 is 0, so it takes out the t. You know what, I'll just do it that way because that's probably how most of you were thinking about this. So let's just do it that way. I lied. We're going to do the second equation for part A here. So this is part A. We're going to use y is equal to y0 plus Vy0 t. By the way, you don't have to do it this way. If you wanted to do it the other way I was just about to show you, and that's better for you, go right ahead. All right, so we are looking for t. Now, if you're doing it this way, first of all, you have to notice that this, because Vy is 0, this t gets zeroed out as well. Okay, this is 0. Otherwise, you will have to do the quadratic formula because we have t squared and a t, and we're looking for t. That means we have to do the quadratic formula. So if you're going to do it this way, the recommendation is to cross out your zeros right away, so that way you don't have to do the quadratic formula. So what we're left with is y is equal to 1/2 ayt squared. I'm looking for t, so I'm going to multiply both sides by 2, so that the 1/2 reduces with the 2. So 2y is equal to ayt squared. I'm going to divide both sides by ay. So I have 2y over ay, though ay's reduce out over there, so I'm left with just the t squared. And finally, I'm going to take the square root of both sides. So I'm left with t, flip-flopping them again, the square root of 2y over ay. Okay, I'm just going to plug in my numbers. Y we said was 380, positive, because downwards is positive. And ay is a positive 9.8 meters per second squared. And so t is equal to, gotta plug in my calculator here. Oops, sorry, 2 times 380 divided by 9.8, take the square root, I got 8.8 seconds. By the way, if you jumped off the Empire State Building, you would also take 8.8 seconds to fall, according to this, right? Because we didn't take into account how big King Kong is, because everything falls with the same acceleration due to gravity. Again, we'll explain that in the future. I just want to point that out again. All right, that was A. So part B here, we need to figure out how fast he's going. So you could either use the first or the third equation. I'm just going to use the first one because it's already kind of set up for me there. So Vy is equal to Vy0 plus ay times t, because I just found t anyway. So all I need to do is plug in my numbers. So Vy is equal to 0 meters per second plus 9.8 meters per second squared times the 8.8 seconds I just found, and I get a number. 86.24 meters per second. This is ignoring air resistance, as I said. Okay. Notice if you're looking at the units here, so we have a meters per second squared here, multiplied by a second. That second cancels out with the squared, and I'm left with meters per second, which is perfect, because that's what I want for velocities. All right. Next problem. Do I have space? Well, we'll see. We'll have to go on the next page. All right. So, next problem is 37. A kangaroo jumps to a vertical height of 2.7 meters. How long was it in the air before returning to Earth? All right. So, let's see, some things to think about here. So kangaroo, well, I'm going to have to draw a kangaroo here. Here is my beautiful kangaroo. It's going to jump up and fall back down again. Okay, it's going to reach a height of 2.7 meters. And it's asking you how long was it in the air before returning to Earth. All right, so some things we know. We don't know the initial velocity. We don't know the initial velocity. We can call the bottom part of this just y0 equals 0, so we'll call the bottom 0. We know the maximum height is 2.7 meters. We know that the top, if we call that the final, that would be 0 meters per second. Because at the top, it's in between, right? Going up or going down. And so at that very moment, at the very top of the jump, the kangaroo is not moving at all. It's at 0 meters per second. It's accelerating downwards with 9.8 meters per second, but it is stopped, right? So it's going to slow down, stop, and then fall back down again. So what I'm planning on doing is going to figure out how long it took to reach the top, and then I know that it's going to take the same exact amount of time to reach the ground again, so I'm just going to double that time. So let's write down our knowns. Y0 is 0, y is equal to 2.7. Oh, I forgot to do something. I forgot to label, I'm going to say up is positive, to the right is positive. I know a y is equal to negative 9.8 meters per second squared, negative because it's going downwards, and I know Vy is going to be 0 meters per second. And I'm looking for time. All right. So there's two ways to do this problem. I'm going to show you the way I think about it. You could do two steps. One would be to find the initial velocity, then plugging it in. Oh, I think that's what we have to do. So first we have to find the initial velocity, and then we can plug it into the first equation to find time. So we're going to use the third equation. So let me talk that through why I picked that. So if you look at the first equation, I don't know Vy0, and I don't know time, so I can't use that equation. If I look at the second equation, I don't know Vy0, so I can't use that, and I don't know time, so I can't use that equation. The only one that I have one unknown is the bottom equation. I don't know Vy0, but I know A, I know y's, I know Vy squared, so I can use that equation, but it just gives me Vy0. I'm looking for time ultimately, so that third equation doesn't help me find time, but it gives me one unknown that I can then use either of the top two equations to then find the real unknown that we're looking for, which is time. So I'm going to use this equation first to find Vy0, then finding time. So the simplest thing here is I'm just going to subtract this whole thing, 2ay y minus y0 from both sides, so that reduces out. And so I have, flip-flopping them again, because I like having my variable on the left. Vy squared minus 2ay y minus y0. All right, and then just taking the square root of everything. All right, so I guess I'll have to use another page here. No squared. All right, so I have this. I'm just gonna plug in my numbers. So I know Vy was 0 meters per second. Squared is just 0. A is negative 9.8 meters per second squared. Y is, we said 2.7 meters. And y0 we're going to call 0 meters. And we're going to take the square root of all that. So we're left with Vy0 is equal to, plug in a calculator, 2 times negative 9.8 is negative 19.6 times 2.7 is negative 52.92. But notice it's 0 minus negative, which makes that positive 52.92, which is great. And then take the square root, and I get 7.27. That seems really... Oh, that's the initial speed, sorry. Okay, I was thinking it's time, and I was like, that seems really long. All right, so that's the initial speed that the kangaroo jumps off with. So now we're going to plug it into that top equation to find t. To find t, we've done this a lot, but it's always good to practice more. Divide by y so that those reduce out, and I'm left with t is equal to Vy minus Vy0 over ay. Now, you may have memorized that or looked back at your notes and seen, because we've done this many times now. That's great. On the test, you will have to show how you do that algebra, though. So keep that in mind, that even though you can memorize it, it's helpful to do the algebra and know how to do it. All right, Vy we said was 0 meters per second minus 7.27 meters per second divided by negative 9.8 meters per second squared. Meters per second squared cancels out with meters per second, unless it's 1 over seconds, and that's good because that's seconds. 7.27 divided by 9.8 is equal to 0.74 seconds. That makes sense. All right, and that is our final answer. Oops, I lied. That is halfway. That's how long it takes to go from the bottom to the top. But then it also takes time to go from the top back down to the bottom. And so we have to multiply that times 2. So it's 2 times 0.74 seconds is equal to 1.48 seconds. That's the total time in the air. That 0.74 was just to the top according to our picture, right? Because we didn't, we could actually, nope, that would just give me 0. Yeah, so that is how we get the total time. All right. We're at now number 39. Draw graphs. Ooh, yay. Draw graphs of the speed and the distance fallen as a function of time for an object falling under the influence of gravity from t0 to t5. Ignore air resistance and assume v0 equals 0. All right, so this is going to be a good one. Let's stop here, and we'll do the next two problems in a separate video just so these don't get too long.